In this class, we're going to talk about the quotient rule of differential calculus. What exactly do we mean by quotient rule? And when do we use quotient rule to differentiate a function? When we are taught to differentiate a function that is dividing themselves, that is, this function has two parts, one at the numerator and one at the denominator. In that case, we use the quotient rule of differential calculus. Let's say we are asked to differentiate this function, y equals to u over v. According to quotient rule, the derivative of y is equals to, you keep v constant and then differentiate u, then you subtract, then you keep u constant, then you differentiate v, then this will be over v squared. If you understand this rule, you'll be able to solve question on quotient rule of differential calculus. You see, the meaning of this rule is that you are going to keep v constant. V is the denominator and u is the numerator. You understand? You are going to keep v constant, differentiate u minus u multiplied by derivative of v all over v squared. Now, let's look at some work example. Let's say you are asked to differentiate 4x raised to the power of 3. Differentiate y equals to 4x raised to the power of 3 plus 8 all over x squared plus 2. All over x squared plus 2. Now, you know that in this function, u is the numerator, though u is equals to 4x raised to the power of 3 plus 8, and v is the denominator, which is what? X squared plus 2. X squared plus 2. Okay? Here, you have to take the derivative of u. Derivative of u is what? 12x raised to the power of 2, and the derivative of v is what? 2x. Okay? Now, having taken the derivative of u and v, don't forget that according to quotient rule formula, derivative of y is equals to v. V is what? X squared. X squared plus 2 multiplied by derivative of u. Derivative of u is what? 12x squared. 12x raised to the power of 2 minus u. You keep u constant. That is what? 4x raised to the power of 3 plus 8 multiplied by derivative of v. Derivative of v is 2x all over v squared. V squared, v is what? 2x squared plus 2. So I'm going to have x squared plus 2 squared. Okay? So this is the formula that I use. Okay? Now, if you have to differentiate a function that is dividing themselves, you understand? When you have a function that has a numerator and a denominator, you can make use of the quotient rule. You understand? Okay? Now, from this point, you can proceed to simplify. Okay? So here, I'm going to have the derivative of y is equals to 12x squared times x squared. That is what? 12x raised to the power of 4. 12x squared times 2. That is what? Plus 24x squared minus 2x times 4x cubed. That is what? 8x raised to the power of 4. 8x raised to the power of 4 plus 8 times 2x. That is what? Plus 16x. Okay? 2x times 4x raised to the power of 2. 4 times 2 is 8. X raised to the power of 3 times x. That is what? X raised to the power of 4. 2x times 8. That is what? Plus 16x. Okay? All over. Now, x squared plus 2. X squared plus 2. You understand? I just expand this bracket. Okay? Now, derivative of y will be equals to 12x raised to the power of 4. X raised to the power of 4 plus 24x squared minus 8x raised to the power of 4. What I'm doing is that I just use this negative sign to open the bracket. So I'm having negative 8x raised to the power of 4. Then use this negative sign to open the bracket as well. You're going to have negative 16x. Negative 16x all over. Now, expand this bracket. X squared times x squared. That is what? X raised to the power of 4. X raised to the power of 4. X squared times plus 2. That is what? Plus 2x squared. 2 times x squared. That is what? Plus 2x squared as well. 2 times 2. That is what? Plus 4. Okay? Derivative of y is equals to 12x raised to the power of 4 plus 24x raised to the power of 2 minus 8x raised to the power of 4. Okay, we can even simplify it, okay, because we have some power that are the same. Okay, So you can see 12x raised to the power of 4 we can subtract 8x raised to the power of 4 from 12x raised to the power of 4 because the power of x is the same for both terms. You understand? So subtract 12 times 12 minus 8, that is what? 4. So I'm going to have 4x raised to the power of 4 minus 16x all over x raised to the power of 4 plus 4x squared plus 4. Okay, so that is the derivative of y. Now let us recap the step. We have to differentiate this function. The first step is that I identify my u and v. U is the numerator and v is the denominator. Now the numerator of this function is 4x raised to the power of 3 plus 8. So u equals to 4x raised to the power of 3 plus 8. The denominator is x squared plus 2. Then v is equals to x squared plus 2. Having done that, I differentiate both u and v because from the quotient rule formula, I need their derivative. Okay? Now, having done that, I got 12x squared as the derivative of u and 2x as the derivative of v. Now, that being done, then I proceed to substitute all this into the formula. You understand? Look at the formula. You can see we have v. We keep v constant, you differentiate u. Then you keep u constant, you differentiate v all over v squared. So u is what? V is x squared plus 2. I have x squared plus 2 multiplied by derivative of u. I got this. You get it. Keep u constant as well, which is this, multiplied by derivative of v, which is 2x, all over v squared. V is x squared plus 2. V squared will be what? X squared plus 2 squared. So I simplify. You can see that it's simple. Okay. So